Welcome. In this video, we'll take a look at another sinusoid function. This time we'll look at y is equal to 4 cosine of 2x plus pi over 3. So let's start by kind of going through our list and figuring out our amplitude, period, phase shift, and a possible vertical shift. First thing I might want to do here is factor this expression on the right side as a 4 cosine of 2 times x plus, if I divide both of these items by 2, I just get x, and then I'll get pi over 6. So if we take a look at this, that would be our b value, and that'll be our c over b, which would be our phase shift. And we'll notice that the d on the end is just going to be a plus 0 if we wanted to write that in. So starting with our amplitude going left to right, we see that a is equal to 4, therefore the absolute value of a is still 4, that's our amplitude. Our period is based off the b value. The period is 2 pi divided by b. In this case, the b value is 2, and so we'll use that as pi. So a period is pi units. Our phase shift is always negative c over b, and so negative c over b for us here is this value going to be negative pi over 6. And so when we consider where we're shifting to, this would be shifting negative pi over 6 units, and that would be a shift to the left. Final thing we could look at is the vertical shift. In this case, there's no vertical shift to be had, so we would have that as a 0. So we have only 3 components to work with: phase shift, period, and amplitude change. So let's next look at our amplitude. Our amplitude is going to be 4, so we'll just measure that out here as our sketch. 4 and negative 4. And now we'll consider our period. We already have the amplitude considered, that's good. Our phase shift, we have our starting point at negative pi over 6. And so next we're going to consider the period. And so when I consider the period, if I add pi units to the starting point, pi units, and then I subtract that starting point, this is going to end up being 5 pi over 6. That will be where my first cycle will end, 5 pi over 6. And so here we'll want to work out this a little bit. Let's see, 1 pi 6, 2 pi 6, just to get our bearings here, that is going to be pi halves. We'll have 4 pi 6, and then 5 pi 6, just to be somewhat symmetric here. So I know I'm going to start at negative pi over 6 and end at 5 pi over 6. So we've got our starting and our ending point here for this given period length. Since this is a cosine function, we know that the cosine function always starts at our amplitude. So when I consider starting at my amplitude, this is a positive 4. I'm going to start at positive 4 for my cosine. If I wanted to consider kind of breaking this down into kind of fourths for each of my points, I know for our cosine function, we're going to start and end at the same spot. So start and end at that same amplitude value. If I consider what is the midway point in between these two, that midway point between 5 pi over 6 and negative pi over 6, we could say is going to be that 2 pi over 6, or pi thirds. So right in between these, we're going to hit kind of the midpoint there. And the last thing we need to do is kind of figure out where kind of to take our quarters. And so if I add together negative pi over 6 plus 2 pi over 6, and then divide by 2, I can get kind of where my middle value is between my low point and my high point here. So this would be pi over 6 divided by 2, or pi twelfths. So pi twelfths would be that point there. And then we'll also want that point somewhere in between 2 pi 6 and 5 pi 6, so to get some point in this range right in between, to get a point in between my halfway point and my full cycle point. So this would be 2 pi 6, and we'll plus 5 pi 6 and divide that by 2 to take the average. So this will be 7 pi over 6 divided by 2, or 7 pi over 12. So this is our midway point, 7 pi over 12. So 7 pi 12ths is right in between here. And let's take a look at just completing this graph. It's not perfectly symmetric, but gives us the values that we need to work with this. It's a little high on this end. I'll bring this down. Get a better looking curve there. All right, so those are our points that we'll want to have there. Starting at negative pi over 6, we'll hit our minimum point at 2 pi over 6, and then back at our maximum at 5 pi over 6. So this gives us the correct shift, amplitude, and then the period for this given function. Let's take a look at one more example with a sine function. So here we have y is equal to negative 2 sine of 4x minus pi over 2. So let's take a look at a factored form here. Y is equal to negative 2 sine 4 times x. If I divide by 4 here, in the interior, I'll have negative pi over 8. So let's consider each component left to right. Our amplitude, A is negative 2, so when I take A is negative 2, absolute value of A here is going to be positive 2. So our amplitude is always positive. The negative 2 does come into effect, and it will flip our graph. Since this is negative, it will flip over the x-axis. So we'll keep that in mind as we graph. If I look at my period, the period is always 2 pi over b. In this case, our b value is 4. Therefore, we're going to make a full cycle in pi half units. And then finally, our phase shift is negative c over b. So negative c over b, that would be negative pi over 8, or that would give us pi over 8 as the phase shift. So we'll set up at pi over 8 for our first point. Last thing, no vertical shift here, so we'll just do a 0 there. So let's consider now working with amplitude, period, and phase shift. We already have the phase shift marked. We can take a look at our amplitude here. It's going to be at 2 and -2. Next thing we want to consider is the period. So I'm going to be doing a full cycle in pi halves units. So let's mark off pi halves units away from our starting point. So this would be, we'll call 2 pi over 8. We'll go 3 pi over 8, 4 pi over 8, and then 5 pi over 8. That would be a full pi halves units in between those 2 points. So from here all the way to 5 pi 8, that's pi halves units. So that's where we're going to fill in our graph. And notice this is nice and convenient because this is kind of chunked up into 4 segments here where my graph is going to be. So whenever I see a sine function that's negative, I always know that sine functions always start at the midline. And since we have a negative in front of our sine graph, we know it's going to be, again, flipped over the x-axis. So when we plot these points, we'll start at the midline where our phase shift was. Since it's negative, we're going to be increasing first. So we'll hit the -2 at 2 pi over 8. Back up at 0 at 3 pi over 8. We'll reach the peak at 2 and at pi halves, or 4 pi over 8. And then back to our starting point before we hit 5 pi over 8. So this will, again, be the general shape of our sine curve, but now it's going to be flipped over the x-axis. We'll be starting going down instead of increasing up. So these are going to be the points that we'll have to plot, and we'll use our Desmos grapher to go out and plot these same points. So hope this is a helpful video working with our amplitude, period, and phase shift. Look forward to seeing you in the next video.